Hello, my name is Diego Romero. My topic is running and motivation.
And my name is Jonas Lee, and my topic is the use of green energy in aviation.
Our presentation is called Variables for Breakthrough by Diego Romero and Jason Lee. So for my topic, I had researched some of the lingering questions I had as a runner myself. And what I had always wanted to know was a scientific reason why I would feel tired or physically stressed out during a run. What I had found was that there are many reasons for why a runner may feel uncomfortable on a run. And a good example of one of these limitations is called the ventilation threshold. So you can think of the ventilation threshold as a spice tolerance, as portrayed in this lovely diagram right here. But instead of capsaicin, the chemical compound that makes food spicy, we are dealing with a substance called lactate, which is produced by your muscles when stressed out. So just like having a spice tolerance, people also have a ventilation threshold that determines how much spice or exercise in this case you can tolerate before beginning to produce lactate and feel uncomfortable. Which brings me to how I interpreted my findings. I guess what I concluded from what I learned was that it is helpful to know when your limits may lie. Because when it comes to running or many other activities, you ultimately are just going to want to enjoy it after. And yes, it is fine to push past your limits in the activity, but it wouldn't make sense if you end up disliking the activity. And finally, for the connection between Jonas's topic and my topic, just like the ventilation threshold, we found many similarities between the challenges people face in Jonas's field of study, the technological slash green energy world, and my field study, the running world. We both got a story that proves this point. So I'm gonna let Jonas take it over for now.
Thank you. So in exercise, right, there is a mentioned ventilation threshold, and anything below the threshold is considered the aerobic zone, and anything above is the anaerobic zone, where the body produces lactate to maintain performance. So in the aviation industry, research into more sustainable flying is taking place. And there are a couple of major routes to get there. So we have fully electric planes, hybrid electric planes, hydrogen planes, and biosynthetic fuels. Each area shares intersections. For example, development in hybrid planes and energy management can also help in the future development of fully electric planes. And it's not beyond the stretch to imagine other overlaps in renewable energy. There are, however, several obstacles in the way of this green future. They range from the low energy density of current lithium ion batteries to the lack of infrastructure in supporting fully electric and hydrogen planes. The unfortunate situation is that some of the technology needed to convert aviation to fully carbon neutral doesn't exist yet. And so at present, development is focused more on maximizing the efficiency and perfecting the technology we already have. So things like perfecting the electric motors so that they run at peak efficiency and power, or in like redesigning more aerodynamic and efficient planes. And we're doing this while researchers are also continuing to explore other battery solutions like lithium air and solid state batteries to overcome some of the major obstacles. So the implementation of electric and hybrid vehicles in the auto industry has several intersections with aviation. The development of hybrid systems and lithium-ion batteries has been admirable and will revolutionize the automobile, but the limits of flying are much higher. And the technology will have the same fundamental design and uses, but the performance bar is set much higher for flying. The groundwork to make it possible is already underway. The search for a battery capable of delivering 1,280 watt-hours per kilogram is still a ways off, but by perfecting the knowns and through more testing in the unknowns, a greener future in aviation may not be very far away. So in this way, the aviation industry is like running. A major part of the development work is currently occurring below the ventilation threshold, where we know the knowns and are perfecting and training in a sense to increase our ventilation threshold. Perfecting the technology in the aerobic zone will make performance well in the anaerobic zone easier and continue to push the limits of the ventilation threshold. All the development is in preparation for when the major breakthrough occurs to be able to capitalize on it and revolutionize the world of flying. And that wraps up my section. Back to you.
All right. So for my story, I went with no other than Elon Musk. And so like the ventilation threshold, there that had lactate as a variable to indicate whether people liked something. For Elon Musk's story of establishing Tesla in 2003, he had his car's performance and accessibility as the variable for its success. And the problem that Elon Musk faced was that before him revolutionizing the technological and production efficiency of electric cars, the only ever fully electric vehicle that was mass produced was called the EV1. So it was far from being tolerable by the larger masses for many reasons. One, the price for ion batteries, the catalyst that powers the electric cars, was much too expensive. Two, the electric motor at the same time was only able to go about 80 miles per hour. Three, the farthest the car could ever go was 60 to 80 miles. And four, there weren't even plans to establish charging stations. So yes, the GM EV1s were a failure and were actually recalled and destroyed due to their performance. So the way that Elon revolutionized electric cars scene was kind of like a person making running likable. By lowering down the variable that makes it dislikable, which in Elon's case was his car's lack of performance and accessibility, he ended up receiving a lot of success for his work, and now has made electric cars much more accessible and by the larger masses. And as you can see in the diagram of Elon Musk's first ever successful electric car, the Roadster, was able to overcome many of the problems the EV1 had by having a top speed of 125 miles per hour, a mile range of 244 miles, which was literally 3 times more than the EV1. And although in 2008 the Roadster may have been at a price of $8,000 to $120,000, the price range would even improve after Elon Musk established factories called gigafactories, which lowered the price of ion batteries, such as now we have Model 3, which is much less expensive. So for the artifact, we just went with a drawing that I made myself, although I'm not much of an artist. But in conjunction to this drawing, we include some philosophy that stated you start climbing a mountain by packing the proper equipment, which is kind of in tangent with what our message is. And so thank you. That's the end for me. Do you join us?
Same here. I hope you enjoyed the presentation.
Thank you.